In this presentation, we're going to go over constructing one population proportion confidence interval. To find a confidence interval for population proportion, we start by collecting data. N would be the sample size and X would be the number of favorable responses. We're going to find a sample proportion p hat, where p hat is X over N, and q hat will be 1 minus p hat. We're going to find a critical value z for desired confidence level. Then we're going to find the margin of error, which is z times quantity square root of p hat times q hat divided by n. Then we're going to use the general format for the confidence interval for population proportion, which is p hat minus e and p hat plus e. And finally, we're going to simplify this answer and round it to 3 decimal places. In a survey of 850 students, 32% of them were in favor of taking online classes. We want to know how many students were in favor of taking online classes. We want to find critical value for constructing 90% confidence interval. We like to compute the margin of error for 90% confidence interval. And finally, we want to find 90% confidence interval for the proportion of all students that are in favor of taking online classes. We're given the sample size and the sample proportion. To find the number of students in the survey that were in favor of taking online classes, using the formula for p hat, if we cross multiply, X would be n times p hat. Replace the values for n and p hat, and we get X to be 272. If this result was decimal, we always round up. The critical value for 90% confidence interval means the middle area is 90%. Therefore, the area on each tail would be 0.05. Using TI command inverse norm with the left area of 0.95, mean 0, standard deviation 1, our critical value is 1.645. To find the margin of error, we need q hat, which is 1 minus p hat. Now we have all the values we need to find the margin of error using the formula. Simplify. The margin of error will be 0.026. Now the confidence interval at 90% confidence level would be p hat minus e to p hat plus e. And simplify this result, and our final answer is 0.294 to 0.346. In a survey of 720 students, 495 of them were driving to a school alone. First, we need to find the sample proportion. Then we need to find critical value for constructing confidence interval. Then we compute the margin of error. And then we're supposed to find the confidence interval for the proportion of all students that drive to a school alone. In this example, we were given the sample size and the number of favorable responses. So the sample proportion is p hat equal to x over n, and we round this to 3 decimal places. For critical value, to construct a confidence interval, when confidence level is not given, we use 95%. That leaves us with 0.025 area for each tail. Using TI command inverse norm with the left area of 0.975, our critical value is 1.960. Now to compute the margin of error, we first find q hat, which is 1 minus p hat, then use the formula for the margin of error, compute that quantity, and we get 0.034. And finally, to build the confidence interval, we go to p hat minus e and p hat plus e, simplify this result, and our final answer is 0.654 to 0.722. Now, how do we find p hat and e when the confidence interval is given? When the confidence interval is given, the p hat will be upper value plus the lower value divided by 2, and the margin of error will be upper value minus the lower value divided by 2. So consider the confidence interval in this example. We want to find the sample proportion and the margin of error. For the sample proportion, we're going to add upper and lower, then divide by 2. So the margin of error in this example is 0.235. For the margin of error, we go upper minus lower divided by 2. And the margin of error in this example will be 0.107. Now let's see how we can find proportion confidence interval using TI. The process is very easy and straightforward. You press Stat, you go to Tests, and you look for one proportion ZINT. Once you select one proportion ZINT, you're going to enter the values for X, N, and the confidence level, and then press Calculate. Your final answer will be on top of the screen. Now keep in mind, X is the number of favorable responses, N is the sample size. If X is not given, but P hat is given, you multiply N and P hat to find X, and if it's decimal, round up. When the confidence level is not given, we use 95%. And we always use mathematical notation to display our final answer rounded to 3 decimal places. In a survey conducted by the college, 9.4% of 175 randomly selected students were left-handed. How many students were left-handed? And then we want to find 90% confidence interval for the proportion of all students that are left-handed. And then we want to find the margin of error. So we're given the sample size and the sample proportion. To find how many students were left-handed, we're just going to multiply n and p hat. Since this answer is decimal, we're going to round up. So x is 17. Now, to find the 99% confidence interval for the proportion of all the students that are left-handed, we're going to go to stat, we're going to go to tests, and we're going to go to one proportion ZINT. Enter the values, and the final answer would be 0.039 to 0.155. So that's the confidence interval at 99% confidence level for the proportion of all the students that are left-handed. And to find the margin of error, we find the upper minus lower divided by 2. I hope this presentation helped you understand how to get started with building confidence interval for one population proportion.